In this video, let's see how we can replace an existing signer list. By the way, there are multiple ways to replace an existing signer list by using master key or its regular key or by using an existing signer list. So if you want to replace the existing signer list using master account's secret key or its regular key, then just follow the code in our previous video wherein we created the signer list for the first time. Use the same code with maybe different SignerQuorum and SignerList as you wish, and sign the payload using the master account or its regular key. That would replace the old signer list with the new one. And remember, you can simply use a regular fee for that transaction as it's not a multi-sign transaction. In this video, I'll show you how an existing signer list can replace itself. That is, we will be using multi-signing to replace the existing signer list. Okay. To start with, let's look at the existing signer list. Let's use account objects command to fetch the current signer list. So the object name is SignerList. Let's check that. Okay, as you can see, our account has only one object, and the object is SignerList object. So this is the list, the signer list with quorum of 3. You can cross verify the accounts and its signer weight. So in this video, let's change the signer quorum and maybe one of the accounts, that is one of the accounts in the signer list. Okay, let's do that in this video using multi-signing, of course. So since we need to do multi-signing, I need to rearrange these things because I need its secret for signing. So let me change these things and derive the account using derive method. And we know that the secret is of type family seed. So let me rearrange all these accounts. So fine, now it's ready for signing. Let me fetch the sequence number from the master account. So the command we need is account info, which outputs account underscore data field, which has the sequence number of the master account. So that's it. Now let's scroll down. Let me uncomment these things. So this is the code from our previous video tutorial. Please watch it if you have not done it already. So let me just collapse this and look at the signing method. This is for single signing. But in our case, master key has been disabled and we are going to do multi-signing. So I'll show you how to do the multi-signing. We need to pass all the derived accounts as elements of an array because it needs multiple accounts to sign this payload, right? So in our case, the signer quorum is 3 and each of these account has signer weight of 1. So in order to meet the signer quorum, we need to pass all these 3 derived accounts, and rest everything is same, the submit command and passing signed transaction to tx blob and everything else. In the payload, you can optionally have this signing pub key field. I say this optional because the library I am using autofills this field. But the important field here is the fees field. For multi-signing, the fees is slightly higher than the regular fee. So the formula is n plus 1 into the network fees. Here n is the number of signatures you plan to provide to this multi-signing. So in our case, we have to provide 3 signatures, okay? So n's value is 3. So 3 plus 1 multiplied by the regular fee. In our case, we have been doing all the transaction with 10 drops. And then don't forget to convert this whole thing into string. Note that the network fees can be slightly higher than the regular fees because by the time you collect all the signatures, the network fee might have shot up. And I have seen people using up to 3000 drops for for a multi-sign transaction wherein they are providing 3 signatures. Okay, it's up to you, but this is the bare minimal, but the transaction might fail if it doesn't meet the transaction requirement of the network by the time you collect the signatures. Okay, so that's one of the key requirements for multi-signing. So going forward, let me change this signer quorum to 2, because in the first video, that is the multi-signing concept, we had a signer quorum of 2 and 3 signers in the signer list, with each of them having a signer weight of 1, which means any of these 2 accounts can make the transaction from the master account. Now let me even change one of these accounts. Let me replace one of these accounts with a new account, because that's what this video is about, to replace the existing signer list. That is, you can replace only 1 or 2 or couple of signers in this list, or replace the entire list. Anything is possible. Okay, in our case, let's just replace one of these accounts. I'll copy the R address. Remember, this is the R address. I'm just having this secret key in the comments so that in upcoming videos, once we change this or replace the existing signer list, we need this secret key to make the transaction. So I just have it in the comments. Now let's replace one of these signers with the new account. So which one? Account 1, account 2, or account 3? So let's replace maybe account 1 with this new R address. Now remember, this new payload has to be signed with the current signer list, that is the derived accounts of the current signer list, which is account 1, account 2, and account 3, which replaces the signer list with this new list. Okay, now let's look at the signer weight. You can have any positive number like 2 or 10, but let's stick to 1, because that way the signer quorum is 2 and we have 3 accounts in the signers as signers, and a combination of any 2 accounts can sign the transaction from the master account. So as I said, this is the important field, that is fees, and I have told you how to calculate that. And that's it. We are good to go. Let's check once again. Oh, we still have a error here. If you look closely, we have changed the values of these constants, that is account 2 and account 3. They no longer hold R addresses, right? So we need to change it. These fields take R addresses and not the derived details. So we need to put this account 2 dot address, which holds the R address of account 2, and account 3 dot address, which holds the R address of account 3. But then replacement constant has the R address. So now everything looks fine. Let me execute this. So the transaction is successful now. So let's get back. Now let's check one thing. Now in the signature, we are still providing the signatures of account 1, account 2, and account 3. But then with our previous transaction, we replaced account 1. So it no longer can authorize the transaction from master account. So let's just try to execute the same payload from the master account once again. And it should throw error. That is, a signature is provided for a non-signer. That is provided with the bad signature, right? So we need to replace it with the derived account of this replacement account for it to be successful. This one. Okay, that's it. Let me comment the whole thing and then check the signer list object to see if the signer list is updated with the replacement address. So let's check that using account_objects command. It outputs a field called account_objects. Let me output the result onto the console window. There is only one object, so I'll input the position to the 0th position. That's it. Let me output the signer list object. So this is the new signer list. You can just cross verify the signer quorum was changed from 3 to 2, And then this is the replacement R address. You can just check it. You can output the account1.address field, or else just check this. This is the replacement R address, which means the signer list has been replaced. So this is how you replace an existing signer list using the current signer list. And I also told you how to replace an existing signer list using your master account or its regular key. So now you know all three methods of replacing an existing signer list. In the next video, let's see how we can make a simple payment transaction using multi-signing, that is in two ways. That is when you have all these three accounts in this single file, or else these three accounts are with three different people and you need to collect signatures from them and then submit it to the network. So let's see that in our next video.